Hey guys, for this video I'm going to introduce you to parallel and perpendicular lines in the coordinate plane. So this should be a refresher from what you've learned in middle school and also what you've learned in Algebra 1. But we're going to go over it and kind of learn a couple new formulas that we'll need in order to determine various properties of parallel and perpendicular lines. So at first glance, I want you to think to yourself, what do you notice? I'm looking at the left-hand side. What do you notice about these two graphs here? And obviously, you should be saying to yourself, okay, well, they look like they're never going to meet because they look parallel. But if I want to pay attention more so, instead of just the lines, to the equations, ask yourself, what do these equations have in common? What's different? I see the slope. The slope is attached to the x value. So remember, for slope-intercept form, we had y equals mx plus b. So the m term, not the x, the m is your slope, which is the rise and the run of your graph. So how much is going up by or how much is going down by. If it's positive, then your graph is going to be increasing. If it's a negative slope, then your graph would be going down slope like a ski, kind of like skiing. So these two lines have the same slope. So that means if they have the same slope, then that's one of the properties of parallel lines. So parallel lines have the same slope, which means these two numbers will be the exact same. Now, if we look over on the right-hand side, we'll see that these two graphs cross at like a T. But that T is a very particular characteristic. It's 90 degrees. It's a right angle. So the kind of lines that cross at a right angle are known as perpendicular lines. Perpendicular lines cross at a right angle. They form a perfect 90 degrees. But let's again pay attention to what the actual equations have. So it doesn't matter if they have the same b or the y-intercept. So this number doesn't really matter. What we care about is the slope. Do you see any similarities between the two slopes? So if I'm asking myself, I might say, okay, I see a 3, I see a 4, I see that one is positive and one's negative. Also, I notice that when I'm looking at the red line, the slope is 3 over 4, but when I look at the blue line, the 3 goes to the denominator and the 4 is now the numerator. These slopes are called opposite reciprocals. Opposite means that one of them is negative, one of them is positive. Reciprocal. So one of them has to be positive, one has to be negative. Reciprocal means flipped. So for example, if I have a slope of 2 over 1, then if it's the opposite, it'd be negative, and if it's a reciprocal, then it would be 1 over 2. So try to think about how maybe 3 over 2 would look. How would 4 over 2 look? So just kind of thinking about that opposite, one's positive, one has to be negative, so one is positive, one has to be negative, and the slopes are flipped, meaning that the numerator becomes the denominator and vice versa. All right, so from these properties, we can answer a couple of main idea questions. So how can you tell from a graph if the two lines are parallel? We know that the lines are parallel, which I think that was actually the straightest lines I've ever drawn, are parallel if the lines never cross. How can I tell from an equation, and it's the m I'm looking for, they have the same slope? How can you tell from a graph if the two lines are perpendicular? Again, we found that those lines are perpendicular if they form that 90-degree angle. Okay, so how can you tell from an equation? They have opposite reciprocal slopes. So maybe you're thinking to yourself, I can't remember how to actually calculate slope. So we use this formula, and this might look familiar after I write it, y2 minus y1 over x2 minus x1. So just like what we did for the distance formula, you pick one of your points to be x1, y1, one to be x2, y2. From here, substituting those values in, so I have negative 2 minus a negative 5 over 3 minus 4. Solving for the top, you can plug this right into your calculator, but it's negative 2 plus 5, which would become 3, 3 minus 4, which would become negative 1. So the slope of this line would be 3 over negative 1. All right, so from here, we want to say, are these two lines parallel? So the easiest way to determine if two lines are parallel is by determining if they have the same slope. Remember, parallel, same slope. So same slope. Okay. So I want to make sure that I solve for both of my equations in y equals mx plus b form or slope-intercept form. This one's good. It's already in y equals mx plus b. But this one I have to manipulate a little bit. So I'm going to solve for y first. So I have 6x plus 3y equals negative 9. Subtract 6x over, I'm going to move that entire expression. Now since it's mx plus b, I'm going to put the x term in front of the actual number. Okay, from here, 3 and y are being multiplied together. So to undo multiplication, we're going to divide by 3. And when we divide by 3, we have to divide by everything by 3 on the left and the right. And what we're left with is y equals negative 2x minus 3. So if it asks us if these two lines are parallel, once you've solved for y equals mx plus b, you'll notice that they both have a negative 2. And if they both have a negative 2, that means, yes, they are parallel. Okay, so we're looking for parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. All right, and the last thing I want to talk about before I stop this video, because these are kind of like the introduction thoughts, is we have seen y equals mx plus b before. That should be fairly familiar. But there's this thing called slope-intercept form. And what slope-intercept form helps us do is it helps us write an equation of a line when we're given a point and a slope. And ultimately what we're doing is we're solving for y. I just erased that. So solving for y and putting a line into y equals mx plus b. All right, we're going to get into a lot of the more difficult and some of the new stuff in the next couple slides. Think about, remember, lines that are parallel have the same slope. Lines that are perpendicular have opposite reciprocal slopes.